Heat Balance Sheet by Dr. H.V. Mulimani, working as Assistant Professor in BGMIT Mudur, Bagalkot District, Karnataka. You can visit my personal website at www.mulimani.webs.com. Heat Balance Sheet. Heat balance sheet is an important parameter as it is an account of heat supplied and heat utilized in various ways in the system. It is something like if we give 100 rupees to the children, it is also important for us to know how and where it is spent, whether it is spent in correct manner or not. Similarly, in engines, we have to know and keep the account of heat supplied and heat utilized. We all know only part of energy is transformed into useful work. The rest of it is wasted and utilized for special application like turbo compounding. Heat which is mainly not available for work is heat carried by exhaust gases and cooling medium. From the experiments, it is observed that 20 to 40% of heat can be converted to useful work. When combustion starts, chemical energy, that is fuel like petrol or diesel, is burned. It is converted to heat energy. This heat energy which is inside the cylinder is indicative power, that is IP. This IP will be transferred to crankshaft by some loss of frictional power, and finally we get a brake power at output shaft. Suppose we get 100 joules of heat after combustion, then all this 100 joules is not converted to brake power. Only 20 to 40% is converted to brake power. Rest will be the losses mainly in exhaust gases and cooling medium as shown in the figure. Figure shows heat balance sheet for typical SI engine and CI engine. As we discussed, we can observe that the useful work is around 20 to 40% only. The others are the losses by cooling, water, exhaust gases and the unaccounted losses. Now let us see how to prepare the heat balance sheet. We can see how much heat is supplied and how much heat is utilized, both in kilowatts. In banking terms, heat supplied is nothing but credit and heat utilized is debit. So heat supplied is the input for us and the output is heat in BP, heat carried by jacket of cooling water, heat carried by exhaust gases and heat unaccounted. In our case, we have an input, that is a heat supplied, and the useful output is heat in BP, and the other three things, that is B, C and D, are the losses. So we have input is equal to useful output plus losses. Heat supplied is given by heat generated by the combustion of fuel, that is QS is equal to MF into CV, where MF is the mass of fuel supplied per minute or per second and CV is the calorific value of the fuel. And heat utilized, under that heat in BP is given by 2 pi nt by 60 in watts or 2 pi nt by 60,000 in kilowatts, where T is the torque. If we use the rope brake for measuring the BP, then 2 pi n into W minus S into R plus capital R plus small r, where W is the weight at the end of the rope, S is the spring balance reading, capital R is the radius of the pulley or flywheel, and the small r is the radius of the rope. If you are using pony brake, then 2 pi n into WL, where n is the RPM, capital W is the weight applied, and L is the length of the rope. If we are using the hydraulic dynamometer, then it will be 2N by K, where W is the weight measured on the dynamometer in meter, K is the dynamometer constant 60,000 divided by 2 pi R, and N is the RPM of the engine. Heat carried away by cooling water is given by Cp of water into mass of water into rise in temperature of water passing through the cooling jacket of the engines, where Cp is the specific heat of water, mass of the Mw is the mass of the water, TWO is the temperature of water at outlet, TWI is the temperature of water at the inlet. Next, heat carried by the exhaust gases is given by Cp of gas into mass of gas into rise in temperature of the gases, where Cpg is the specific heat of the exhaust gases, TGE is the temperature of burnt gases coming out of the engine, TA is the ambient temperature. A part of heat is lost by convection and radiation, as well as due to the leakage of gases. Part of power developed inside the engine is also used to run the accessories like camshaft, lubricating pump and water circulating pump. These cannot be measured precisely, and so this is known as unaccounted losses. This unaccounted heat energy is calculated by the difference between the heat supplied and sum of A plus B plus C. The results of above calculations are tabulated in the table, and this table is known as heat balance sheet. In general, the heat distribution is represented as in the percentage. This is also tabulated in the same heat balance sheet.